Hey everybody, this next video lesson is going to discuss the energy that is absorbed or released when things change states of matter. This is called energy of phase change. A phase change is a transition between solid and liquid or liquid and gas. We're going to talk about the energy lost or gained by the transition between solids, liquids, and gases. Now in a previous video lesson, we've discussed solids, liquids, and gases, and we talked about how that solids particles are usually stuck in place, wiggling with little movement. The particles are packed together very closely. They have a definite shape and a definite volume. The liquid, on the other hand, the particles are spread out a little bit because we add heat to convert from solid to liquid, so the particles have freedom to move. They rotate in place, maybe even bump into each other a little bit more, and they will fill the container they are in. So they have indefinite shape but a definite volume. And finally, gases have lots of space to move around because as we add more heat, we are transitioning from a liquid to a gas, and the particles begin to move around very freely, and they fill the container so they have indefinite shape, and also the particles can be compressed or pushed together so they have indefinite volume. There's lots of space with lots of movement. Now the transition between solid and liquid, well, we know is something that we experience here in Minnesota in the springtime. When the ice on the lake turns to liquid, we call that melting. On the other hand, the opposite of this is when liquid turns to solid, something we experience in the fall and the winter. Even right now, in this current state, we are in a cold situation where the liquid water is eventually going to turn to a solid. Now, that is called freezing. Now, in melting situation, since we're going from a solid to liquid, we are adding heat. And what we learned in a previous video lesson is when you add heat, we call that endothermic. So melting is endothermic. Now the opposite then must be true from liquid to solid. If you are cooling down, then you are releasing the heat. You see, the liquid water releases the heat out, which allows for the solid particles to form, and freezing then is considered to be exothermic. So it's important that you associate these vocabulary terms, endothermic and exothermic, with a phase change or a state of matter change. Endothermic is melting, exothermic is freezing. Now let's look at the transition between liquid and gas. Liquids, when heated, turn to gas. You experience this whenever you boil water on the stove. You are adding heat to the water, and eventually the liquid turns to gas. We call that boiling. But a more technical term is called vaporization. The opposite of vaporization is when gas turns to liquid, and the gas particles cool down and form liquid particles. Maybe you've experienced this when you've taken a hot shower and you get out and you look at the mirror and you see the mirror has a bunch of fog, a bunch of water particles. It's condensation because liquid has condensed from the steam in the air to liquid on the mirror, and condensation is when the gas particles slow down to become liquid. Just like melting and freezing, vaporization and condensation can be associated with endothermic or exothermic. You see, liquid is going to gas, that is endothermic. Vaporization is endothermic because the liquid absorbs energy in order to achieve that. On the opposite hand, gas turns to liquid, it condenses, and condensation, or condense, is exothermic because the gas has to release its energy in order to become a liquid. So here's a quick summary of the states of matter change and the endothermic or exothermic situation. Melting and vaporization, or moving to the right, and the phase change diagram means that you are adding energy, and these are always endothermic. Whereas anytime you're going from high energy to low, you're going from gas to liquid to solid, you are then releasing your energy and you are exothermic. But there's something strange that happens during these phase changes or these transitions between solids and liquids and gas. Normally, if you take a solid and you add energy to the solid, the temperature of the solid heats up the more energy you put in. The temperature goes up as the heat goes up. And same with the liquid. The temperature goes up as the heat goes up of the liquid, and the same with gas. But something really strange happens in these transition periods between solid and liquid, where the matter isn't quite solid and it isn't quite liquid. It's in this state between solid and liquid. You can imagine what I'm talking about in the form of like slush Is it solid? Is it liquid? It's a bit of both. Or humid air, liquid, gas, or a bit of both. If you think of really, really hot, steamy air, if you just got out of the shower, you breathe in that heavy, liquid feeling air. Is it liquid? Is it gas? It's a bit of both. These transition periods, something happens strange. You add heat to convert from solid to liquid. But when you add heat, the temperature doesn't change during this transition period. It's true at the liquid to gas transition as well. The temperature does not change when we add heat. So going from liquid to gas, we're adding heat, but the temperature remains constant. The same is true if you're going down. If you're decreasing the energy, then energy is being given off, but the temperature doesn't lower during these transition states. When you go from liquid to solid, you are giving off energy. The liquid is releasing its energy to turn to solid, but the temperature doesn't change. Now, the temperatures at which solid turns to liquid or liquid turns to solid is called the melting point, and that temperature for water is 0 degrees Celsius. Now, the transition between liquid and gas or gas to liquid is called the boiling point, but that temperature is 100 degrees Celsius. And while all the substance is solid and it's turning to liquid, it will not change temperature until every last particle stops being a solid and turns to liquid. The same is true with liquid to gas. While you're boiling the water doesn't continue to get higher temperature as you heat it up. It stays at 100 degrees Celsius until all of the liquid has turned to gas. It is quite an interesting phenomenon. Check out this video that I've created for you that shows how the temperature remains constant during a phase change between solid to liquid and liquid and gas. What you're looking at is a beaker full of ice water, and the ice water is on this hot plate. Now, you don't see the controls, but the hot plate is turned on really high, and this is a thermometer sticking out. Now, this thermometer is connected to my iPad, and in a moment I'm going to start the video, and you'll be able to see the data start to populate a graph in the upper right-hand corner of this screen. Now, this data collection took over 20 minutes to do, and I've compressed it and sped up the video so that we could watch it in less than a minute. So I'm going to go ahead and hit play now, and we'll see what we're looking at. What you see is the temperature staying pretty consistent over here, even though the heat is on. And you'll see that the graph zooms in every once in a while to rescale. But see how the line is laying flat, because there's still some ice in here, as you can see. But soon the ice disappears, and now the graph takes off in an upward trajectory. And this is the point of the video that I really sped it up. So this is super fast speed. And we're getting hotter. 30 degrees Celsius, 40 degrees Celsius. Coming up on 50 degrees Celsius, 60 degrees Celsius. First, it was flat because it was still as ice. As I mentioned, the heat was added, but the temperature didn't go up initially. Not until all the particles turned to, did the particle start to increase its temperature. Now we're reaching the point of about the boiling point. You can see the graph start to kind of level off here, but you'll see it actually levels off much quicker as we approach boiling. So now we're boiling again. Do you see this down here? All the bubbles? Watch the graph. It stops going up and turns a sharp right-hand turn. It stays consistent at 100 degrees Celsius. As long as the liquid is boiling, it will not get above 100 degrees. So heat is being added to the water, but the temperature stops going up because temperature does not increase during a phase change. When you saw it early on, the temperature was holding flat at about 0 degrees Celsius. Only once all the ice turned to liquid did the temperature begin to go up. And then once again at 100 degrees Celsius, we saw that the temperature stopped going up because we were going from a liquid to a gas. So in summary, temperature change does not happen in a phase change. When you're going from solid to liquid or liquid to gas, the temperature remains constant. That is contrary to what you think. Normally, when you think the heat goes up, the temperature must go up, but that is not true during a phase change. Anyway, that's it for this video lesson. Thanks for watching.